Hello everybody, so today we will be entering chapter 2 which is on capacitors and dielectrics. Okay, so there are, I think there's three or there's three, yeah. So there's three subtopics in this chapter, and the first one that we will be looking into is the capacitance and capacitors in series and parallel circuit. Okay, so in this subtopic, you should be able to define and use capacitance, derive and determine the effective capacitance of capacitors in series and parallel. And then lastly, you have to be able to derive and use the energy stored in a capacitor. Okay, so these are the symbol of a capacitor. So it can either be two straight parallel lines, or it can be in this shape lah, right? So this is a capacitor. So if you see a device like this, it is actually a capacitor lah, right? So what is the function of a capacitor is it can store electric charges or electric potential energy. Okay, so it is a storage lah. Okay, so it consists of two conducting plates separated by a small air gap ataupun a thin insulator known as dielectric. So the uses are for photo flash, on-off switches, smoothen the direct current voltage lah. Okay, so what is capacitance? Capacitance, on the other hand, is a measurement of the ability of a capacitor to store charge. Okay, so it is a measurement lah. Capacitance ni, it is a measurement untuk kita tahu berapa banyak storage dia boleh store. Berapa banyak charges it can store. Okay, so it is a scalar quantity, and then it has the unit of coulomb over volt, ataupun you can just write farad lah, F. Okay, so the ratio of the charge on either of the plate to the potential difference can be calculated using the formula here. Okay, so if you want to calculate berapa amount of charge, it is the amount of charge is by using this formula, ataupun for capacitance it is C equal to Q over V lah. Okay, Q is the charge, V is the potential difference ataupun voltage. Okay, so untuk capacitance, it is constant. Okay, so when the capacitance of a capacitor is constant, we can see that Q here is directly proportional to the potential difference. Okay, and then the charge stored is directly proportional. Actually this is the same thing. This is just in sentence. Okay, so basically the greater the capacitance, the more charge is required. Okay, so 1 farad pula, it is equal to the charge of 1 coulomb stored on each of the conducting plates as a result of a potential difference of 1 volt between the two plates. Okay, right, so that is the explanation of capacitance. And then make sure you are able to not actually memorize, understand that 1 charge of coulomb stored is due to a potential difference of 1 volt. Itu je dia punya explanation of 1 farad lah. Okay, right, so capacitor in series, this is a series circuit. So how do we calculate the effective capacitance in a series circuit is by using this equation here. So how do we get this equation is, we know that the magnitude of the charge for a series circuit is equal. Okay, so the magnitude of charge untuk each of these are equal. And then the potential difference, we can, untuk calculate the total potential difference in a circuit, we have to add each potential difference of this capacitor lah. Okay, so because of that, we can then let Q out of the equation. Then we then get the effective capacitance punya formula jadi begini. Okay, so what you need to know for series circuit is the magnitude of the charge is the same, and then the total potential difference is the addition of each volt of the capacitor lah. Okay, alright, so that is capacitor in series, and then let's look at capacitor in parallel. Okay, so for parallel circuit, dia punya drawing schematic diagram is like this. Okay, so untuk capacitors in parallel, instead of the magnitude of the charge being equal, the one that is equal throughout all this circuit is the supply voltage, ataupun the potential difference is the same as the supply voltage. Okay, so because of this, we then get okay, before that, and then dia terbaliklah dengan the series circuit. Instead of V yang instead of V yang kena add here, kita guna untuk di total charge. Okay, untuk parallel circuit, the total charge is not equal across each capacitor. It is the addition of each capacitor untuk dapat di total charge. Okay, boleh faham? Because of this and this, we can use this equation C equal to Q over V to get the effective capacitance. So the effective capacitance untuk parallel circuit can then be calculated using this formula. Okay, so make sure you are able to remember which formula is used untuk parallel ataupun series circuit. Okay. Alright, let me check if this is the theory part, if we finish the theory part. Okay, no, not yet. Right, so energy stored in a charge capacitor pula, which is U. So let's look at when a switch in a circuit is closed, charge will begin to accumulate on the plates. Okay, so in order for us to calculate the energy stored, which is U, we have to relate it with work done. Okay, so because of this, a small amount of work is done in bringing a small amount of charge from the battery to the capacitor. Okay, so mathematically we can write that as this one here, and then the total work required to increase the accumulated charge from 0 to an amount is given by this integration here. Okay, so dapat sudah ini integrate, then we'll then get the formula to be this one lah. Okay, so basically energy stored is equal to the work done in bringing a small amount of charge from the battery to the capacitor. Okay, contohnya ni battery begini, then we need that small amount of work done untuk bring the charge from the battery to the capacitor here. Okay, so we have to calculate the amount of work in order for us to calculate the energy stored in the capacitor lah. Okay, alright, so that is that, and that is the end of the theory part for our first subtopic, which is on capacitance and capacitors in series and parallel. The most important part for this subtopic is you have to be able to calculate the effective capacitance and basically simplify this diagram so that you can easily calculate the effective capacitance lah. Okay, alright, so that's the end of our first subtopic.